All right, so we're gonna do problems 1 and 3 today. And we're going to do them just preparing for our next, I know we just had a test, you guys are like, we just had a test, but we're already preparing for the next quiz. This is on it. These are the problems that I'm going to have you leave an exact form on the quiz, but we're going to check our answers with the graphing calculator. The first thing I'm going to do is write at the top of my paper. That helps me figure out what trig function to use. And next I will label the sides that are marked already with opposite, adjacent, or hypotenuse. By the way, you may have noticed that this paper is extremely wrinkly. If you're in my access class, you know that's because I spilled a lot of water on my desk one day. So this packet is going to be wrinkly. And I'm forcing myself to use the packet and not use a new one. It's very out of my comfort zone, but it's going to be fine. Okay, so 20, is that opposite, adjacent, or hypotenuse? Hypotenuse. And x, opposite, adjacent, or hypotenuse? Adjacent. Okay. Which one of our trig functions is adjacent and hypotenuse? Cosine. Cosine 67 degrees equals adjacent over hypotenuse. That's as far as you can go without the calculator. And now we're going to get the calculator and make sure that it's in degrees, please. 20 times cosine 67. 7.8. Any questions about number 1? Okay, number 3. Is it cosine again? I think it is. 17 is hypotenuse. 7 is adjacent. Haha. Come over here, sir. Actually, don't come over here. Go back over there. Grab a card, and that will tell you what table to sit at, and grab a packet. I just caused some extra steps. I'm sorry. And then your phone goes in here. I'm sure you're number 5. What with your last name? Okay. So we have cosine again. Cosine theta. There's a question mark here. You guys can choose the variable. You can use x. If you like, I use theta when it's angle equals adjacent over hypotenuse. Theta equals cosine inverse 7 over 17. That's exact. And then cosine inverse 7 over 17. 65.7 degrees. Yes, dear.
On a test, are we gonna get like marked if we don't put this zero equals?
Theta equals?
Yeah.
Well, it's telling you to solve for theta.
Yeah. So yeah.
I didn't do it on this last test on the quadratic formula problem. A lot of people didn't put the x equals in the front. I didn't mark it off, but I probably will start to because I've warned. So just try to do it as best you can. Any questions about either of these two warm-ups? Again, your next quiz is, let's look, actually, if you flip your paper back over to the stamp sheet side, it's not for quite some time. It's not this week's block day, but the next week's block day. I already know the topics. One of them is going to be trig. This, what we just did, so. Okay, notice that today we are doing notes on transformations, but your homework is actually in the packet. It's a worksheet. So just set your packet aside. You're definitely going to have time to work on that class today. The notes are not going to take us all period. So just find this guy here and then set him aside. And then go ahead and set this up. All right. So today we're going to review transformations for parabolas. This is another math 2 thing. What we're doing today is actually the second problem from your quiz. So one of your quiz problems, it's not going to be up. It's like a full week and a half from now. One of them is going to be trig. One of them is going to be this. This should be stuff that you kind of already know, but it's super good to go over. The rest of math 3 is going to depend on you knowing this. So super important. Okay, first, this value, K, hanging off the end, determines how up or down the parabola is going to be. So shift up or shift down. So what we do is we say, if you have a positive K, that's a shift up. And if you have a negative K, that's a shift down. Okay. H. If you have x minus h, that is a shift right. And if you have x plus h, that is a shift left. Okay, now we're going to write the A stuff. The A stuff is more complicated. If you have a negative A value, that is a reflection across the x-axis. If you guys have a parabola, you'll know the negative in front turns it into a downward parabola. You guys had one of those on your team test, remember? Opens down. Okay, now the next things I'm going to write are the way that I want you to say transformations for A. You're going to have to tell me if this is the way you learned it or not. I'm not sure, but this is what I want. So we'll see. If the absolute value of A is greater than 1, what I mean is just the number. Just looking at the number, that is steeper. And I want you to say vertically stretched by a factor of A. Have you heard that before? Vertically stretched? Never? We're going to practice this in a few minutes. Don't worry. Okay, and then this is going to look weird. Just bear with me for a sec. Okay, so what I want you to think about, you guys picture, like pretend I have a parabola, like pretend I'm standing on the vertex and I'm holding the two sides of the parabola. You guys know what I mean? Like picture the U shape. Okay, so I pretend I've got a big rubber band, and I probably should grab a big rubber band for this, but if I step on the vertex with my foot and I'm holding the sides of the parabola, vertically stretched means that A is greater than 1, and I pull like this, and it gets steeper. Can you imagine? So it's regular, pull, that is an A value greater than 1, so like 2 or 3, makes it steeper. You can kind of visualize it when it's steeper. Okay, then same parabola. Instead of having A greater than 1, I have a fraction or decimal in the front. That's that notation, just somewhere between 0 and 1. Compressed means I push it down and it gets wider. So that's what I mean by vertically stretched and vertically compressed. So skinnier, wider. Okay, there's a couple of other things you need to know. Do you know what the, so first of all, do you know what the parent function is for a parabola? It's a question that's so easy, it's hard. It's y equals x squared. That's the parent graph. Do you guys know why we call it the parent graph? Because that's the like normal one. And then all of these changes we're gonna make are all of like its little variations. Okay, now what I'm gonna do is I'm gonna take this. This is super important and extremely helpful for children. I'm gonna take this parent graph and I'm gonna rewrite the parent graph into vertex form. Okay, let me say that again. I'm gonna take the parent graph and I'm gonna rewrite the parent graph into vertex form. Have you heard the words vertex form before? Or graphing form of a parabola, vertex form or graphing form, that's this thing here. Okay, so if I want to take this, I don't want to change the value of this at all. I just want to make it look like this. It's extremely helpful. I'm going to put a 1 in the front, x minus 0 squared plus 0. Okay, why did I do that? I did that because sometimes you need to have stuff in the box for it to make sense. On this one, it's easier to see the transformations. It's easier to see the vertex is 0, 0. Okay, but let's talk about changing the value. So x squared, I want it to be x squared. Doing x minus 0, will that do anything to it?
No.
No? Okay, and then multiplying that by 1, will that do anything to it?
No.
No. And then adding 0 at the end, will that do anything to it?
No.
Oh, okay, and this is really important because when you guys have one that doesn't look like this, you'll be able to make it look like that, just like you want it to. Okay, now for the next minute or two, I'm just gonna look at this. I'm going to type some equations into Desmos, and we're gonna practice doing this transformations, like saying the things. So you guys don't have to do anything. You can just sit there looking cute. Okay. I put the parent graph in. Let me see if I can, it's not gonna let me zoom in more than that. Oh, here we go. Okay, so I put the parent graph in. Everybody okay with that being what the parent graph looks like? Going through 0, 0, regular old parabola. You guys good? Okay, now what I'm gonna do is I'm gonna make that parent graph into vertex form. Did I change the graph at all?
No.
No. Okay, so I really need you to trust me there that I didn't do anything to change it. Okay, but now I am going to change it. Okay, so leaving the red one where it is, what happens if I change this number out here to a 1? It goes up 1. Okay, so on the quiz, you would say shift up 1. That would be the description of the transformation here. Everybody okay with shift up 1? You're like, yeah, this is easy, Mrs. Talbot. I know it's easy. That's not a bad thing. Minus 3. Shift down 3. Those would be the words that you would actually write on the quiz. Shift down 3. Everybody good? Okay, now I'm going to come in here. This one has 2 transformations. I would say shift right 2, down, shift down 3. 2 separate little bullet points. Shift right 2, shift down 3. Super important, by the way, in this problem, A is 1, H is 2, not negative 2. It's 2. You remember how we did the rational functions and like off to the side, I did like x plus 3 equals 0, x equals -3. Same thing with this. And then -3 is k. So you have to switch the sign of h because it's in the parentheses, and that's going to be consistent all year long. Okay, let's move it left. So I would say shift left 4, shift down 3. Okay, here's the question in this problem right here, this green one. What is A? 1. What's H? -4. And K is -3. You guys with me? Is this way too easy? Okay, now I'm going to take this 1 and switch it to a -1. Yes, you're stretching. Okay, go. Okay, this one has 3 transformations, so on the quiz I would put 3 bullet points. I would put down, it doesn't matter the order, but down 3, left 4, reflection across the x-axis. Is that okay? All right, and then lastly, steeper, not as steep, steeper, even steeper, no, even steeper. Okay, so what would I say? I would have 4 bullet points for this. Reflection across the x-axis, vertically stretched by a factor of 3.
Wouldn't it be like reflection across y equals -3?
Depending on the order. You're supposed to reflect. So you're supposed to do them in a certain order. But you don't have to write them in a certain order on our quiz or test. Just say reflection across the x-axis because that's what it would be before you shifted it up or down. Okay, so order of operations. First, you would move it right or left. Does it make sense now? Then you would vertically stretch and compress it. Then you would reflect it. Then you would move it up or down because of order of operations. But I'm not going to make you guys do it in that order. That would be okay. But I do want you to say all 4 of them, which is reflection across the x-axis, vertically stretched by a factor of 3, left 4, down 3. Okay, now last thing, let me show you a decimal one. Or fraction, whatever. Okay. What would this one be? Do you guys know the words? The decimal and fraction. The only thing we haven't done yet. Vertically compressed by a factor of 0.25. Or this could be 1/4 a fraction of 1. Vertically compressed by a factor of 0.25, left 4, down 3. Do you feel like you can do that? We're going to practice it again in just a minute. Oh, while we're here, let me show you your joke for the day. We're going to do 2-1 to 2-3 review of transformations. We're right smack in the middle of it. And I'm going to put up the box for you to read for trigonometric ratios. The thing I don't like is that the book doesn't go in SOHCAHTOA order. It makes me mad, but it's fine. And your homework is the chapter 2 day 1 worksheet. And this is my joke. Do you get it? Do you get it? Last problem. So we're going to practice this like you're taking the quiz in a week and a half. But that's okay, because I'm recording this, so you can come back to and watch this video right before the quiz. put it in your short-term memorials. All right, so we're gonna attempt to do this with no calculator, because the teacher doesn't allow you to use those on physics. So we're gonna attempt to do all the math, this whole set of problems here without a calculator. It's gonna be fine. I promise it's gonna be fine. For this one, we'll see about this one. Okay, so first thing I'm gonna do is identify the vertex. How can I get the vertex from this? Yep, right 5 down 2. So my vertex is right 5 down 2. Okay, right after I write this, I'm going to put the vertex in the middle of my table because that's going to be the middle point on my graph. Right 5 down 2. Okay, then I'm going to go to my table and be like, okay, then this has to be 6 and 7, and this has to be 4 and 3. Anybody lost so far? You're all good so far? Any questions at the moment? Okay. Now what we're going to do is math to fill in the table. So 4 minus 5 squared minus 2. 4 minus 5 is -1. What's -1 times itself? 1 minus 2 is -1. And by symmetry, this one also has to be -1. So these aren't so bad because you really only have to do 2 bits of math because the other ones should match. Okay, 3 minus 5 squared minus 2. 3 minus 5 is -2. -2 squared is 4 minus 2 is 2. 2, 2, 2. Okay. Now, real quick, I have a lot of advanced people in this class. I want to address anybody who's looking for efficiency. If your A is 1, you can cheat and go over 1, up 1, and over 2, up 4. Okay, again, if your A value is 1, only if your A value is 1, you can cheat from your vertex, go over 1, up 1, over 2, up 4. Why? Because 1 squared is 1 and 2 squared is 4. You can use this trick to help make your table, but be very careful with it, because if A is anything else, you can't use it. Okay, and we're not done with this problem. We're going to identify A, H, and K and create the transformations. Okay, in this problem, A is 1. Do you guys all see the 1 right in the front there? Nothing there means it's a 1. Okay, H is +5. K is -2. You do not need to put a transformation for A equals 1, because that's the usual. Shift right 5, shift down 2. This would be a perfectly completed quiz problem. You identified A, H, and K, describe the transformation to graph it using 5 points. Do we need a calculator? No, we do not, Mrs. Talbot. Okay, we might need one a little bit for this one. We'll see. Okay, first, what is the vertex for B? Perfect. -3, 1. Gorgeous. A equals 0.5. H equals -3. K equals 1. Okay, what would I write for A equals 0.5? Vertically, yep. Yep. Perfect. That's my space saving attempts. Any questions about what I've done so far? Okay, now what numbers need to be in my table here? What's this one going to be right here? -2, -1, -4, -5. Now I'm a lazy human being, so I'm going to do the easier numbers for the math. Mrs. Talbot, you need to make that table over a couple of spots on your page next time. Indeed. Okay, so -2 plus 3, 1. 1 squared is 1. 1 times 0.5 is 0.5 plus 1, 1.5. Okay, now what does negative 4 have to be by symmetry? 1.5. Okay, negative 1 plus 3, 2. 2 squared, 4. 4 times 0.5. 2 plus 1 is 3. That wasn't that bad. Wasn't that bad.